array, first you have to take the number of rows. We will use a two nested for loop. In the outer for loop, we will limit the number of rows. How many number of rows we have to mention that, and the inner for loop will limit the columns, number of columns. So outer for loop always limits the row number. Inner for loop always limits the column number. Now, if you look into this for loop, I have four rows over here from 0 to 4, less than 4. That means 0, 0, 1, 2, 3. So from 0 to 3, so row is less than 4, we will go to this for loop. So if I have the 0th row, so at the 0th row, which is less than 4, so we will go for the column number 0, and we will check the condition. Column number 0 is less than the total number of columns in here. Yes, so we will go ahead to print whatever inside the for loop. We will execute that. So I have just printed the for loop with this. So name of the array, inside the indices, as we have to mention the row and column number, it is just a way of printing. Okay, so that's why row number, column number, %d, because both of them are integers, which is equals to actual elements, which is also integer. So %d format specifier. So row for this one, column for this one, and the array name with the indexes, row number, column number, we will put it in here. So this is how we actually print the two-dimensional array. So let us run this example. Okay, this is how your elements of the array are, two-dimensional array are placed in the memory. 0th row, 0th column, 12, 0th row, column number 1, 13, 1, row 1, and then 0th column, row 1, column 0, 14, row 1, column 1, 33, so on so forth. Okay, this is just one way of printing the two-dimensional array elements. So I will be sharing with you all these documents. I want you to go through this codes one by one. I am explaining the codes to you right now so that when you are trying to execute them, so it will be easier for you to comprehend. And also try to modify these codes. All right, so what I did in here. Okay, so this part you're familiar with. Actually, I have taken two-dimensional array, two square brackets. It is two-dimensional array. What is the type of array? Integer array. Okay, and this is our array name, and we have for 3 rows and 3 columns. Okay, so for each row, 1 row, 2nd row, 3rd row. So after each row, we have to place a comma. So let me rephrase it in another way. Suppose you have, without this braces, you can give this curly braces in order to differentiate, in order to make your code more readable. Or if you want, you also don't have to necessarily mention these curly braces, but commas you have to give. And the number of elements must match the dimension of this array, because we have, for the first row, 1 2 3. Okay, 3 columns, so 1 2 3. Second row, 1 2 3, 23 45 66, 3 elements again. For the third row, 3 elements again. Okay, if we did not if we did not put the curly braces, that would have meant the same thing to us. But you have to be sure that the number of elements over here must match the dimension, otherwise it will give you an error. Now with this part, we are already familiar with how to print the array elements. Okay, this is the method how you do, using two for loops, nested for loops. Outer for loop will denote the row number, inner for loop will denote the column number for that particular row. Okay, that is why it's like this, two nested for loops. So this is for printing the elements of two-dimensional array using nested for loops. Now if you want to read the array elements, okay, so our read function was scanf, and the type of data we are taking from user. Okay, that format specifier we need to take in here. Okay, and we have to pass the address of the variable where your user input will be stored. That means what? Our array element ij, row I, column j, and in that particular array element, the address, in that particular address, we are going to take user input. Okay, let us run this example. Okay, as usual, we are printing the elements of the array. So this was our array. This was our array, and we 1 2 3 23 45 66 4 2 1. Now it's time to take input from user and filling up the array. So we are filling up our two-dimensional array, taking user input. Hope you are able to hear me. Are you able to hear me? Is it okay? Hello, is it okay? Or is it too feeble or something? Is it okay? Are you here? Are you able to hear me?
Yes, ma'am.
Okay. So I am taking new elements, filling up my array with new elements. So first row is complete. Second row is 167 again. Third row is 300, 301, 302. I have read the elements of the array. That means input the elements of the array. The last part, I'm just printing the new element. So whatever element were there in this array initialized, okay, those were replaced by the user given input. Okay, and our new input will be element at 2 1 index 2 column number 1. What is our value? Okay, that is array 2D, name of the array, and we are passing the row number and the column number. So that was our output. can do several multiple applications. Actually, these two-dimensional array are very much needed, various matrix computation, various vector calculation. We need this to multi-dimensional array. Not only this, if you have a clear idea, clear concept of this multi-dimensional array, this multi-dimensional array is also used to store binary images. The images are for ith row, jth column. Each of your image is made up of small pixels. Those pixel values are stored inside a multidimensional array. So if you are doing any data processing with the image processing, even in any codes, say Python or any other codes, you will find this helpful multidimensional array. So with this, you can do machine learning also. Okay, for each of these pixel elements, several algorithms that are designed, okay, with multidimensional array, and they do various kinds of calculation. Okay, uh, various neural network problems that are solved with this arrays. Okay, not only that, you will find a huge library of functions with multidimensional array. Okay, so these are your basic concepts. Okay, example, for your recap purpose, I will take another example. I have taken a two-dimensional array of row 4, column 2. So for we have 4 rows over here, and for each row we have 2 elements, so 2 columns. Okay, that's what this one means. So after array initialization, okay, you have to give the end of statement, that is a semicolon. But inside, when you are giving the elements of the array, that means you have to give it will be comma separated. So this is this is our basic concept, that how you print the elements of the array. Second is using the index numbers, row number, column number inside 2 for loops. So first row will be reached, then that after that, reaching the row, we will reach the column of that row. That is why first the row, then the column number. Okay, so with 2 square brackets, I will pass the row as index, column as index, and starting from 0 to the number of elements, number of rows and number of columns, I will print all the elements one by one. This is with indexing. Now you are already familiar with this kind of printing of elements of array. The second way of representing the array is with the dereferencing operator, okay, or value at an address operator. So this one you are already familiar from your last class, this particular way of writing the syntax. So first we have to mention the name of the array plus the index number. So up to this we were familiar. Up to this we were familiar in our last class. We know how to print the elements of the array using value at an address or dereferencing operator. Now, for printing two-dimensional array, what happens inside the first bracket? So you give the name of the element, name of the array first with the index of the row. That means you have to reach the row. So this one will be evaluated as your row, and at that particular row we will have the column. For that particular row we will reach that particular column, and if we take the entire value, okay, for that row and that column, so we are at that particular address now. This is our address now. Value at an address is this one. Is it clear to you? So we are already familiar with this kind of notation. So we have to give the array name, and we have to give the index number, and that will give us our address of the array, of that element of the array. And in order to print the value, so we will take the dereferencing operator. Now for printing the two-dimensional array, we will first reach the row number. So this will give our row number of that particular array. This will provide us row number. That means that address of that particular element which we want to reach. Address, okay, not the value. The total that will give the value at this particular address. So this is how you print the two-dimensional array with dereferencing operator. Okay. Okay, let me run that example for you. Okay, so you can already see the first way of representing that we are already familiar with, this one. Okay, so first way of representing is this. Second way of representing is with dereferencing operator. See, both of them are giving us the same result. Okay, same result it is giving. All right. We have talked about the integer arrays. So this is an example of character array, of two-dimensional character array. Okay, so check it. Right. So this is our two-dimensional character array. Okay. So row C, for this particular way of representing, I'm initializing this sum array, two-dimensional sum array. Okay. Character array type. You have to mention the column number, otherwise it will give you error. You may or may not mention the row number, but you have to mention the column number. Okay, so this is one way of representing. So row, so we have 1 2 3 4, so we have 4 rows, and for each row we have how many characters? 1 2 3 4 5 6 7 actually. 7 actually, because you have to take the null character as well. So so this is our first array. This is the same array has been denoted like this way. So next is we put the row number. Okay, and this is how we print the array using the dereferencing operator just we described above in the previous example. So we will take two for loops. The outer for loop is for the row number. The inner for loop is for the column number. For that particular row number, we will reach the column numbers. All the columns present in here, we will reach that. Okay. So we will check if the column number is less than the our mentioned okay, less than 6, less than 6. So if it is so, column number is less than 6, our limit, we will print the elements of the array. So we are printing the characters, single character at a time. So this one is the address of our row. So this one is the address of our element row column. This one is the value stored at an address. Okay. So we have the something like that. And column row. Okay. This is represented like this way. Okay. So if we go ahead and execute them, we will get that. Okay. We will get the elements of the array printed as usual. So this is two-dimensional character array. This is a simple example. What else we have? Oh, that's it. Okay, for two-dimensional arrays, we have this simple example. So we will go further. So let me come with the pointers. So for the pointers, actually, what is a pointer? Let me describe them one by one. So we are already familiar with the address of operator ampersand. So what this address of operator does, it prints the address. It gives you the address or the memory location where your data is stored. It just gives the memory address, your main memory address. That is why it is called address of operator. Let me see. Okay, so we look into this example. I have taken, say, I have taken unsigned integer, which is initialized to 21, unsigned short integer, which is initialized to 1, unsigned long integer, just like this, and long integer of minus some number. Now I have taken and this integers, and I have stored these integers in some variables, and I want to see what are the address. First, I have printed the numbers with their variable names. Is it visible to you? Okay. Okay, I have printed the variable names. In the next line, I have printed where these variables are stored in the memory using our address of operator or the ampersand, this sign. Okay. For variable A, wherever it is stored, give me the address. So ampersand A. For variable B, give me the address. So ampersand B. So on and so forth. So for each of these variables, I have printed the address. So for the this you are now. Okay, let me run this example. I did not. We are here with different of variables. Okay, this particular variable actually is used to store the address of the operand. In many cases, it is useful using the variable name directly. We can tell the compiler use its location. Use the location. Okay, go to that location, then do whatever operations you need to do and get back the result. So in order to take the address, okay, notation, so we store the address in a pointer. So that hello. Okay, am I audible? Okay. If you see, I have taken the example from previous case that unsigned integer a, b, c, long integer type d, simple integer e. Okay, and for each of these variables, okay, I have used pointers. So naturally, pointers stores the address of the variable. So address of the variable is given by ampersand a, ampersand or ampersand whatever the variable name. Okay. Now, how to define a pointer? So whatever variable you are trying to point to, whatever variable you are trying to store its address, check its data type. Whatever data type is provided for that particular variable, you have to use the same data type for that pointer. Okay, so that means for the pointer a, pointer ptr underscore a will store the address of variable a. It is storing the address of variable a. So our notation of pointer is same data type. This operator, this sign looks like multiplication, looks like dereferencing operator, but it is not. So it is pointer. So data type, pointer, the name of the pointer. So suppose I am trying to store the address of variable a using the name of a. I have used ptr underscore a. That means it becomes easier for my programming purpose. So this is our pointer notation for a. I am storing the address of a inside a pointer variable, this is how I initialize a pointer variable. Similarly, for variable b, I am storing the address of variable b in ptr underscore b. How do I define it? I look into the data type of b, see unsigned short b. That means I have to use the same data type for the pointer also. Then the notation, star notation. Then the variable pointer variable name equals to, I am already declaring and assigning. That means I am initializing this pointer with the address of b. Similarly, for c, variable c, I'm storing the address. This is unsigned long c, so we use that data type for the pointer of c. For d, we use same notation. For e, we use same notation. Okay. Now let us come to, so this is how a pointer is initialized, declared and assigned and initialized. Okay. So data type, then star notation, then name of the variable where your address will be stored. So this variable actually holds the memory address of a, where your a is located. Okay. So if I print the first, what I print the values of just a b c d, just print the values. Okay. Then I print the address where these variables are stored in our memory using ampersand or address of operator. Same address I have printed using pointer variables. So this means whatever that the value this gives, the same value will be given by this, because these are holding the address. This is the address of a, this is holding the address of a, so this means these only. So if I run this example, okay, if you are able to see the output of the screen, so our value are normally whatever it was, 21b, so and so forth. Address of variables of a, b, c are stored using the ampersand operator. I have printed the address. Using the pointer, I have printed the address. Both are same. Okay. So this is the function of a pointer. It simply points to the memory location where your variable is stored, or it holds the address, memory address, where your variable is stored. So we can either directly use ampersand a to get the address, or we can use the pointer to a just like this way. This notation, data type star, the name, variable name, and which holds the address of a. So we will use this notation or this notation to get the address of this variable. So this is a simple basic concept about pointer. Okay, let us take another example. Okay, so I have taken some variable which I initialized to 44. I have taken a pointer variable of type. So this is a pointer variable. Okay, this points to integer type of data. That's what this statement means. Students, can you please mute yourself? Okay. Priya Singh, you need to mute yourself. Okay, so first is, okay, so that's what I was telling you. This is a pointer variable which points to an integer type of data. Now, since I haven't given anywhere to point to, I have initialized it with 0. Normally, this is a, you can say it's a uh, way of coding. Okay, if you use it like, you could have done it like this way also, but I prefer it like this way. So initialize it to null. That means it is not pointing to anything, it is just null point, pointing to null, nothing. This avoids dangling pointers, what we call, later we will see while handling memory or heap locations in memory. Okay, there are cases where programmers accidentally have kept dangling pointers, so which may create programming errors. So it creates different kinds of bugs. Okay, so normally what we do, once we initialize a pointer, either you give the address of the variable name or you just put it null. Okay, it avoids the dangling pointer references. Now, so some case, this is the some variable that I have printed, printf with the printf statement. So since it is integer type, so %d, then I have tried to print how many bytes it is taking, how many bytes this variable is taking in the memory. So I have used the size of operator. Then I have used the address of operator to print where it is located in the memory. So it will give me the memory address with unsigned integer format notation. This is what the printf statement means. Then I have assigned this pointer to the address of this variable. Okay, so now I have used this pointer to locate this variable. So this pointer now holds the address of some variable. This means the address of some variable which is assigned to our pointer variable. So since pointer variable now holds an address of this one, so I will print the address. Let us see what happens if I run this program. So our variable is 44. The size of the variable, since it is an integer variable, so in memory it takes 4 bytes of memory, occupies 4 bytes of memory. And with this is the address with ampersand operator. This is the address with the pointer variable. Both are same. Okay. Is it clear to you up till now? Is it clear to you up till now?
Yes, ma'am.
Am I audible? Students, is it
Yes,
clear to you up till
yes, ma'am.
now? Okay. Means in order to read the address which is stored in this variable, we use simply this notation. Okay, pointer to int. See this notation. No star or any notation before this variable name. Okay, this will give us only the address. But when you are declaring it, you have to give the data type, the star notation, the variable name equals to, you can give 0 or you can just keep it simply like that. It's up to you. But I prefer it like this way. It avoids dangling pointer references. So, okay. So far now we know that pointer is a variable which holds the address, which stores the address of another variable. Okay, pointer is a variable which gives us the memory address where our other variable is stored. Okay, it simply gives us the address. Pointer simply gives us the address, okay, or the memory location or the memory address. That's it. Okay, again, this is another simple example. I have taken an unsigned integer, my var, which is equals to, I have initialized it with 33. So this is our initialization of the variable my var with 33. And I have taken a pointer which points to unsigned integer data type. So I have initialized it with 0. That means it's not pointing to anything. It is just null for now. Null pointer. It's not pointing to anything. Now comes the assignment part. So this one should point to address, should point to this thing. That means this, the address of my var is this one, which is stored in this variable. Since this my var is of type unsigned int, so my pointer has to be of data type unsigned int. Okay, so this how I assign this value, the address of my var, to this variable. Now I print the whatever value in simple, whatever value in my var. Then I print the address where this is stored, either using simply this or using simply this. So I have used this notation only. So I have used a pointer to print wherever my this is stored. Okay, simple assignment. Now this is another example. So this is a one-step initialization. This is assignment, how you assign values to pointer variable, assign addresses to pointer variable. This is how you initialize them. So I have taken variable how old, which is 50 of type data type unsigned short int. I have taken a pointer same type of name ph, and I have immediately assigned it with the address of this one. Okay, this is initialization. This part you know. See, I have, okay, this is interesting now. So I have assigned or initialized what value should our pointer variable hold. So what I'm trying to print now, I want to get this. Okay, this notation, so this is particular, only this part is our ph. Ph is a pointer variable which holds the address of this one. So it holds the address. Whatever value at an address, so whatever, so this means what? Actually, this is replaced with, so star of dereferencing. Now I am dereferencing. Dereferencing means value stored at an address of this. So value stored at an address, this actually is 50. So this is simply dereferencing the, I am dereferencing or taking the value at an address, this, it will give us 50. So using pointers, I have printed the address, but if I print the value at an address operator before pointer variable, it will give me whatever value is stored in this variable. Is it clear to you? So this you are already familiar with. This part, dereferencing operator, you are familiar with. Do not confuse it with this statement. Never, ever, ever confuse it with this statement. This is how I declare a pointer. But when I use a star before the pointer, that means value at an address, whatever is this, value at variable, whatever is this. So since this is an address of this one, whatever value is in here, 50, that will be printed. Okay, this is dereferencing our this variable. Okay, so this was our variable initial, our first statement. This is our variable, and the address of this variable is this one. Now how old is equals to 50, which I got this statement. Okay, how old is equals to value at an this, whatever it is holding, value at the memory address this. So value at the memory address, this is how old is 50, which is just like this one, 50. How old is equals to 50, which is this statement. If you want to see what is the value actually present in this variable, pointer variable, that means what is the memory address is in the pointer variable, I will just simply take the pointer variable. Okay, not the dereferencing operator, not this one. Okay, this, whenever you type this star before a variable name, that means value at an this variable. Since this holds an address, value at an address, this simply an address, this prints a value. For this discussion, I hope that you will be able to differentiate pointer, what is dereferencing, so on and so forth. Don't confuse. The more you practice, you need to practice. Okay, if you practice, it will become easier for you to understand, and it will be easier for you. Okay, so this is an example. This is actually important for this pointer notation and for your important for rest of your chapters. So if I go through strings and all, everything you will know the pointers. You have to know the pointers. So please be sure to make it clear. This is how we define a pointer. Data type, star notation, variable name, that means a pointer. But if I write somewhere in here star the variable name, that means value at an address of this. This is the difference. Okay, what is the purpose of this code? I have taken a number 10. Then I have taken a pointer which is of type void. Now you can say that void pointer means what? It can point to anything. So this one will be important for you when you will use the memory allocation techniques. Normally, malloc function in the C for memory allocation gives you void type pointer back. So in order to use it in your code, you need to typecast it with the respective. That means you to convert it into the type of particular data type you want to point to. See, our pointer is of type void, but it is pointing to a integer type data. Okay, so that means what? It has a huge scope. Void pointer means it can point to anything, any number, any data type. But later on, you have to convert it to the respective data type. Okay, so first type of pointer is void, which is pointing to, so which stores, rather I will say, which stores the address of number. So this is our number variable. This is our address of operator, which is give the address, memory address of the number variable, which is assigned to our pointer unknown. So void pointer unknown is initialized to the memory address of the number, points to this number. And the second line, next line, I have taken another pointer. I did not do anything with it. So I did not, I just kept it as it is. I just declared it. A variable of which points to, which is a pointer variable, which points to integer type of data. So first data type, then the star notation, then the variable name. That means it is a pointer of integer type of data. That means this one should point to integer type of data. This one should hold the memory address of an integer type of data. Now the trick comes. Since this is a integer type of pointer, that means this pointer points to integer type of data. So I have assigned our unknown pointer, which is of type void, whatever value it is holding, which is holding the address of number now, which is pointing to the number now, it is assigned to our this variable, this pointer variable, which is of type integer. Now this is, since this is a void pointer, I cannot work with a void pointer. This is rule. I cannot work with a void pointer. I need to convert it. So I have converted the void pointer of to type integer pointer. So this is typecasting. So this is now, this means what? Whatever address is in here, that is the address of a type integer, which is stored in our PTR number variable. That's what it means. Our next statement is what? Our next statement says I am in order to print the value number, I have used the dereferencing operator. So this was our void pointer. Simply this much is our void pointer. Since I have to convert it first to integer pointer, that means I have typecasted it to integer pointer. Now, whatever value is at this address, okay, I want it. So value at an address. So whatever value at this address, that is printed in here. Okay. Whatever this pointer unknown, which is converted to integer type after dereferencing, gives the same thing is given by PTR number, which has been assigned to hold the address of this indirectly. Let me run this example. So I want the value. See, so the first part is a type conversion from void to integer type of pointer. Integer type of pointer, that means the memory address. This is our memory address. The value at this memory address is 10. Similarly, the value at this memory address is 10. Is it clear to you? Students, is it clear to you? Students, am I clear to you? Okay.
Yes, ma'am.
So I hope that you will be able to do different kinds of programming with the pointer variables, okay? So you just go through these examples one by one, modify the code, try to update yourself, okay? Do more programming on pointers. So our basic knowledge is when we declare it, so data type, star notation, and the variable name, that is our pointer. But when we are using it, the pointer variable name, if we have an value at an address operator, that will give the value of this one. Only this is pointer, and this is value at an whatever this pointer is holding. Okay, this part, this example you are already familiar with. I have shown you in the previous class actually what is the purpose of our dereferencing operator. It is a recap again. So in a main function, I have taken one-dimensional array, initialized array 2 with some numbers, with some values, three elements. Then I have found the number of elements in the array, okay, with the size of operator just discussed previously, and stored that number of elements of array inside our this variable size array. Now I am just printing the values of this array using dereferencing operator. Inside the for loop again, so I will print the values of the array. This is again a recap version. This is array name. Array name means the address of the first element of the array plus I The i's index, I can be from 0, 1, 2 up till the number of elements. So up to so I0, I1, 2, so on. That means address of those respective elements, value at an address of the elements of the array using dereferencing operator. I hope it will be clear to you, uh, so you don't confuse it with pointers. Okay, this is a simple printing of array elements as usual with our index I index notation with brackets, and this is with the dereferencing or value at an address operator printing. Both of them are printing the same thing using the dereferencing operator, using the simple index notation. So you don't confuse with the pointers now. Okay. Right. So this is another simple example. I have taken an integer variable initialized with 10. I have taken a pointer variable which I have initialized with null 0, null pointer. It's not pointing to anything. Then I have assigned address of this variable I, address to this pointer variable, simple. Then I have printed with the dereferencing operator whatever value at an address operator, whatever this thing points to, value at that particular memory address, whatever value at that particular memory address, that is printed. Then I have changed the value. So you can guess what value it is going to print. Can you guess, students? Students, can you guess the first line where what is going to print? Students, are you sleeping? Are you slept? Are you sleeping? What happened? No answers. So are you confused now?
10.
Exactly, 10. It will simply print 10 because this is holding the address of this one, and whatever memory address we have, whatever value at the memory address we have it in here, that is the 10, it is going to print. Now I have changed the value from 10 to 99. So this is our memory address. Whatever value at the memory address is now is equal to 99. That's what this statement means. Okay. So if I do that and I print this statement, simply by using the pointer notation, simply by using the pointers, I have changed the value at the memory address var1. So whatever var1 was holding previously, now it is updated to 99 using the pointer notation. Okay, I am manipulating directly with the memory address now. So whatever memory address I have in here, so the value at that memory address should be 99. That's what it means. So this was initially pointing to var1, which is stored in this memory address. So now var1 is updated to 99. That what this program means, instead of using another copy, see here example, var2 is equals to var1. Okay, now if I would have print say var2 is equals to comma var2. So I have printed the value of var2. Okay. আচ্ছা I sorry এটা I ছিল I what is happening in here, why I am telling you this. Now var2, see from here, var2 I have taken another variable var2 in a memory which is a copy of var I. So I have made a copy of var I in memory which is named as var2. Now whenever I change this, now since var2 is now in here, var2 is 10. See, var2 is 10. Simple. What if I change var2 to 90? And after that, let's see what happens. So initially it is 10. Now it is var2 is 90. So var2 is, we are printing. So var2 comma, so var2 first it will be printed, then var I will be printed. Let's see what happens. See, initially var I was 10, then var2 was given as a copy of var I. That means it is holding 10. Now I accidentally change var2 to 90. But whatever copy the var1 had, it is not changed. Still 10. Okay. That means if I use a function, if I try to pass values between two modules using imitation, okay, using imitation or copy of the variables, it is not going to reflect. However, if I directly use the address, I use the address or the pointer, that will directly affect our actual original variable. Okay, so we will see when I use this simple notation, that means the copy. When I manipulate it with pointer, that means we are originally updating the value. So whenever you are using a pointer variable, be sure, be careful while handling with the pointers. It will update our original variable. This one means copy, but this is our original. Okay, let us come to some other examples. So when we see when I see you in the next class, maybe on offline, okay. If it is an offline class, I want you to practice them in your lab. Practice all the examples that have been discussed in your lab. Okay, you practice them and try to update them, and I will see them, check them. Okay, have you given the assignments, all of you? Have you given the assignments?
Yes, ma'am.
Okay. uh, I will check those copies, and with few more assignments I will give. Okay, with that I will give your internal marks, internal examination marks. Okay. So okay, let me finish this. All right, this is example of array, an array with pointers. This I think I have explained to you in the previous class. No, not with the pointers. I did not explain this one. Anyways, so I have taken in this particular program, I have taken an array of data type double. So this is our array and it has 5 elements and it is of type double. So storing double elements. So this is initialization of the array. Then I have taken a pointer of type double. So data type, star notation, and then the variable name. This is our declaration of pointers. Now I will initialize, I will assign. So that means this variable is going to hold the address of some variable that is of type data type double. So now I have assigned the value in our variable p. Since p is our of variable pointer, since p is a pointer variable, so p is going to store the address of some variable. Here we can see only balance. So if I do this, you already know the name of the array means the address of the first element. কিসে কখন এখন থেকে? Okay, students, I have to attend a meeting in here, so I will finish the class in here only. So let me explain, go through this code, and I will finish the class. And if any more students left with the attendance, you may give it. Okay, so what I have done, so this is the address of the first element of the array. So this is assigned, address of the first element is assigned to our pointer. Simple as that. Now what I am doing inside the for loop, I am printing the elements with our value at an address operator. So pointer, which is storing the first address of the first element, plus the index, that means for consecutive elements I. So this is going to give the address. This is going to give the value at those addresses. So with the pointer, I am printing the elements of the array. This is what this program code means. Okay. Since this value is going to be double, so that is why I have taken format specifier LF. Same notation, Same thing, instead of the pointer variable, I have used the array name which you are already familiar with. If I run this example, see, the first thing is printing the elements of the array using the pointer. So p plus 0 is address, whatever stored inside p, plus 0 means that address only, that means the first element. The address of the first element, the value at an address of the first element, which is equals to this one, which is already our array. When the for loop is incrementing one by one, all we are getting the value at those addresses. Okay, the same program with the without the pointer notation, with the simply using dereference operator by on the name of the array. In here we use dereferencing operator or value at an address operator on the pointer. It is just that. Students, I end this class up to this much. Okay, I share the up to here only, and your attendance. So roll number 61, give your attendance please. Roll number 61, 62, 63, 64,
Yes, ma'am.
65,
Yes, ma'am.
67, 69, 71, 72,
Present, ma'am. 72.
73, 74, 75,
Present, ma'am.
76,
Present, ma'am. Ma'am,
77.
76 present.
Okay, 77, 80, 84,
Ma'am, 81 present.
হ্যাঁ দিয়েছি দিয়েছি
Ma'am, roll number 80 present.
আচ্ছা 80 প্রেজেন্ট, ঠিক আছে। 88, 89,
Present, ma'am.
91,